Hi, today's chapter is on ratios and proportions. Ratios is just a mathematical way of comparing two quantities. Let's take a look at some simple examples. So suppose I have 7 men and 9 women in a room. I'd like to compare the men and women in this room. So I can say the ratio of men to women is 7:9. I use a colon to separate the number of men and the number of women. I can also say the same statement or the same information in other ways. I can say the ratio of women to men is 9:7. I can also give the information in a third way. I can say the ratio of women to total number of people in the room is 9:16. And of course, I can also give the ratio of the total number of people to the men in the room. So, total to men would be 16:7. So, we are just comparing two numbers, and that's a ratio. Equivalent ratios. Let's see what this means. So, let's say I have a ratio of green baskets to red baskets as 8:6. It is given that the ratio of green baskets to red baskets is 8:6. Let me first ask you a question. Does it mean that there are 8 green baskets and 6 red baskets? No, it does not mean that. It means that for every 8 green baskets, there are 6 red baskets. This is a comparison between the two numbers. I can easily say this comparison in another way. I can divide both sides by 2 and say that for every 4 green baskets, there are 3 red baskets. This is giving the same information. Because if for 4 green baskets, there are 3 red baskets, then surely for 8 green baskets, there are 6 red baskets. For every 4 here, I add 3 on this side. For every 4 here, I add 3 here. Similarly, I could write the ratio as 16:12. I've just doubled both sides of the original ratio. So the ratio hasn't changed. So what's important in the statement 8:6 or 4:3 or 16:12? They are not giving the actual number of baskets there are. They are simply comparing the number of green baskets to the number of red baskets. So ratios do not give actual numbers, they compare numbers. A useful way to understand ratios is to write them as fractions. So 8 green to 6 red can also be written as green upon red is equal to 8/6. So the fraction of green baskets to red baskets is 8/6. And now we can reduce this to 4/3, or we can hike this up to 16/12. So when you write it as fractions, then the equivalent ratios become easy to understand. Here the fraction of green baskets to red baskets is 4:3. Let's now relate ratios to actual numbers. The colors red and blue are mixed in the ratio 5:4. So red is to blue is given as 5:4. Question 1. If 27 gallons of the mixture is prepared, how many gallons of each color are used? So now I'm given the total. The total is 27 gallons. And I need to know in this 27 gallons, how much is red and how much is blue. So the first thing I do is go back to my ratio, which tells me what is the relationship between the red and the blue. So I know the red to blue is 5:4. So what would be the total in this case? The total in this case would be 9. If there are 5 red, then there are 4 blue, and so that total is 9. Question 1 tells me that the total is 27. So I need to relate these two totals. One way to do it is to say that a total of 9 has become a total of 27. So red, which was 5 parts of the 9, becomes how much? Well, that's easy. That's 5 over 9 into 27. That's 15. So the 5 would become 15. How about the blue? That was the red. The blue was 4 parts of the 9. How much does it become? It becomes 4 over 9 into 27. That's 12. So the blue will become 12. So when the total is 9, I have 5 red and 4 blue. So when the total is 27, I've hiked up the total 3 times. So I got to hike up the red 3 times and I got to hike up the blue 3 times. And here are the well-known calculations. They come under many names. They come under unitary method. They come under direct proportion. Question 2. 20 gallons of blue was used. What's the volume of the mixture? Remember the ratio. Red, blue, total. 5:4:9. Now we are given the information that 20 gallons of blue are used. So this is given as 20 and I need to find the total. What's the volume of the mixture is the question. So I need to find this out. The commonsensical approach would be 4 has become 20. That means I've hiked it up 5 times. So the total will also go up 5 times and this will be 9 times 5 equal to 45. The other way to do it would be ratio of total to blue is 9 over 4. So 9 over 4 is equal to what over 20. And I cross multiply and figure it out. X is equal to 45. So any way you want to set it up, you get an answer of 45. Let's move on to a ratio of 3 quantities. Just as I compare 2 quantities in a ratio, I can compare 3 quantities. So here, red to blue to yellow is being compared. The colors red, blue and yellow are mixed in the ratio 4:7:2. So what does this mean? It means that I take 4 parts of red, 7 parts of blue and 2 parts of yellow and mix them. What's the total? So in this mixture, there is 7 plus 4, 11 plus 2, 13. There are 13 parts mixed. If 52 pints of the mixture is prepared, the mixture contains how many more pints of blue than red? Okay, slightly more complicated wording. The calculations will be the same. So here I'm given that the total is 52. And how many more blue than red? So obviously I need to find blue and I need to find red. And I know how to find them given the total. So let's call the blue B. So let's write the ratio. Blue to total, I know, is 7:13. It is also B, the unknown, is to 52, the given number of pints. So I calculate B. B will turn out to be 52 times 7/13, which is 28. How about the number of red gallons? Red to total is given to me as 4:13. And now with 52 pints of the total and R as my unknown for the number of red pints, I get R over 52. So R works out to be 52 over 13 into 4 equal to 16. So now I found out the actual number of pints of blue is 28 and the actual number of pints of red is 16 in this total mixture of 52. And the question is, how many more pints of blue than red? Which is a simple subtraction, 12. The answer is C. Let's turn the question around. The colors red, blue and yellow are mixed in the ratio 4:7:2. Same thing. If there are 25 more quarts of blue than yellow, then what is the total volume? So this is the reverse of the earlier question. In the earlier question, they gave me the total and they asked me how much more of blue was there than red. Here they've told me there is 25 more quarts of blue than yellow. Find out what the total was. So we proceed along the same lines. I have red is to blue is to yellow is 4 is to 7 is to 2. What's the total? The total is, as last time, 13. Well, there's one more piece of information. It's given that there are 25 more quarts of blue than yellow. So in this ratio, how much is blue minus yellow? Well, blue minus yellow is 7 minus 2 is 5. So in this ratio, or in the total of 13 quarts, there are 5 more blue than yellow. Clearly, because there's 7 blue and 2 yellow. So let's set it up. My ratio is blue minus yellow over total is 5 over 13. And I'm given that there are 25 more quarts of blue. So if I'm given this is 25, find the total, T. So I solve for T. T is 25 times 13 over 5, which is 65. C again. So this is an important way of doing things. I did not find separately the number of blue and the number of yellow because that's not the information given. The information given was that there was 25 more blue than yellow. So I found out in terms of the ratio, what is the ratio of blue minus yellow to all the other given ratios. And then I proceeded. How do we connect ratios? A is to B is given as 4 is to 15. B is to C is given as 5 is to 7. B is to C is given as 5 is to 7. Since B is common, I've written the column for B only once and I've written 2 values under it. B compared to A is 4 is to 15 and B compared to C is 5 is to 7. The question is, what is A compared to C? They want to compare A to C. What does the first statement say? The first statement says if there are 15 parts of B, then there are 4 parts of A. And statement 2 says if there are 5 parts of B, then there are 7 parts of C. So obviously the answer is 4 is to 7, right? A is to C? Well, obviously not, because A is 4 when B is 15 and C is 7 when B is just 5. So A can't be 4 when C is 7 because the B's aren't matching. So the first thing I have to do is make the B's matching so that the 2 statements can be compared. So how do I do that? How do I make the B's common? Well, this is 15 and this is 5. So I multiply this ratio by 3. I should be in a good place. If I multiply the second ratio by 3, I get 15 is to 21. Now I can get rid of this ratio. And now I see B is the same. So when B is 15, A is 4 and C is 21. So I can write the ratio as 4 is to 15 is to 21. Now I've managed to get a common ratio involving A, B and C from the 2 individual ratios. Now I can answer any question they want. They want what is the ratio of A is to C. That's just 4 is to 21. Answer D. 2 integers are in the ratio 3 is to 5. If each number is increased by 10, the ratio becomes 5 is to 7. The numbers are, so let's call the numbers X and Y. So X is to Y is 3 is to 5. I can also write this as a fraction. Let's get used to writing it as a fraction. X upon Y is 3 upon 5. That's given. If each number is increased by 10, that means I add 10 to X and I add 10 to Y. The ratio becomes 5 is to 7. So when I add 10 to X and 10 to Y, the ratio becomes 5 is to 7. The numbers are. So here are 2 pieces of information and 5 answers are given. I try out the answers. The answer that satisfies both these equations is the one I'm looking for. First choice, 3 is to 5. Of course, it satisfies equation 1. What about equation 2? 3 is to 5. So this would become 13 over 15. 13 over 15 does not reduce to 5 over 7. So A is out. What about B? B is 10 is to 14. But 10 is to 14 is not equal to 3 is to 5. So it does not satisfy the first equation. C. 12 is to 20. 12 is to 20 does reduce to 3 is to 5. I can divide both by 4. And it does become 3 upon 5. So it does satisfy equation 1. How about equation 2? For that I have to add 10 12 plus 10 over 20 plus 10. That's 22 over 30. And that will not reduce to 5 over 7. So C doesn't work either. How about 15 over 25? I'm going to work here. 15 over 25. That is 3 over 5. When I add 10 to each, it becomes 25 over 35, which does reduce to 5 over 7. I can divide both by 5 and that becomes 5 over 7. So D is my answer. I'm going to introduce a very neat calculation trick here. It's called componendo and dividendo. We've learned it in school, but many of you would have forgotten. So let's say we are given two equivalent ratios. That means X is to Y is the same as A is to B. Is the same as. For instance, 2 is to 3 is the same as 4 is to 6 or whatever. I'm going to manipulate these ratios to get new ratios which are also equivalent. Since these two fractions are equal, treating them as fractions, I can add 1 to both sides. So I can say X upon Y plus 1 is equal to A upon B plus 1. Taking the LCM and adding the fractions, I get X plus Y upon Y is equal to A plus B upon B. So here's my new ratio. That means if X upon Y is equal to A upon B, then X plus Y upon Y is equal to A plus B upon B. I can add the numerator and denominator in the top on both sides, keeping the denominator the same. And the two ratios are still equivalent. I could have instead subtracted 1 from both sides instead of adding 1 to both sides. So it would become X over Y minus 1 is equal to A over B minus 1. Proceeding along similar lines, I'll get X minus Y upon Y is equal to A minus B upon B. So subtracting the denominator from the numerator from both ratios again gives me equivalent ratios. So I have two equivalent ratios. I have X plus Y upon Y is equal to A plus B upon B, and I have X minus Y upon Y is equal to A minus B upon B. I can divide both sides. I can divide left side of 1 by left side of 2 and right side of 1 by right side of 2 because everything's equal. So the Y's will cancel on the left and the B's will cancel on the right, and I'll get X plus Y upon X minus Y is equal to A plus B upon A minus B. Of course, X minus Y should not be 0 and A minus B should not be 0. That means X should not equal Y and A should not equal B. Those are the only conditions for this division to take place. And I get my most important formula that if X by Y is equal to A by B, then X plus Y upon X minus Y is equal to A plus B upon A minus B. And this formula is called componendo and dividendo. The first one was called just componendo, the second one was called just dividendo, and putting them together I get componendo and dividendo. So obviously the next example will underline that fact. 3x minus 5y upon 3x plus 5y is equal to 1 over 3. What is the ratio of x's to y? Or what is x divided by y? 3x minus 5y over 3x plus 5y is equal to 1 is to 3. So since I have x and y both in the numerator and denominator, I want to get rid of y in the numerator and x in the denominator. Let me try componendo dividendo. So let me do 3x minus 5y plus the denominator 3x plus 5y. In the denominator, I'll do 3x minus 5y minus 3x plus 5y. Here I'll add numerator and denominator. Here I'll subtract denominator from numerator. Proceeding. The 5y's cancel in the numerator. I'm left with 6x. The 3x's will cancel. In the denominator, I'll be left with minus 10y. The right hand side, I'll get 4 over minus 2. So I'm left with 6x over minus 10y equal to 4 over minus 2. and they want x by y, which is now simple. 4 into minus 10 over minus 2 into 6. Let's clean up things. That's 20 over 6, which is 10 over 3. That answer is C. So a direct application of componendo and dividendo help us solve for x and y quickly. Moving on. 4 employees worked overtime on a project. The overtime earnings were in the ratio 2:3:5:6. If one of the 4 employees earned 30, which of the following cannot be the total amount earned in overtime by the 4 employees? Let's write the long ratio. X is to Y is to Z is to W. Denoting the 4 employees by letters, I get 2:3:5:6. So this is the earnings of the 4 employees, and this ratio, that is, what is the total earnings? 5 plus 5, 10 plus 6, 16. So the total earnings is 16. Now, if one of the 4 employees earn 30, which of the following cannot be the total? So suppose X earned 30. So X earned 30, what can the total be? So 2 has become 30, what does 16 become? So 2 has been multiplied by 15, I'll multiply 16 by 15, and that's 240. So E cannot be the answer because I can get 240 as the total. If X earned $30, then the total would be 240. So E is out. Let's say Y earned the 30. That means the second employee earned $30. So his ratio to the total is 3:16. 3 becomes 30 by multiplying by 10. I would have to multiply the total by 10 to get 160. Is that an answer choice? C. So C is out. I can get 160. What if Z becomes 30? Z to total, the ratio is 5:16. If Z is the $30, what is the total? So 5 to 30 is 6 times. So 16 times 6 would be 96. That's answer choice B. So B is out too. What about W? W to total is 6:16. If W becomes 30, that means I've multiplied 6 by 5. I need to multiply the total by 5. 16 into 5 is 80. 80 is choice A. Choice A is also out. So the only choice missing is D. So the answer is D. The total cannot be $192 if one of the employees earns $30. A 12-gallon barrel contains pure strawberry syrup. 4 gallons of the contents are removed and 4 gallons of water are added. So you're basically diluting the syrup. This is done twice in succession. What is the final ratio of strawberry syrup to water in the barrel? Simple. I remove 4 gallons of strawberry syrup and I put 4 gallons of water. Then I again remove 4 gallons of strawberry syrup and I put 4 gallons of water. So I've removed 8 gallons of strawberry syrup and I've put in 8 gallons of water. Whatever question is this? Finally, there's going to be 12 minus 8 of syrup and 8 of water. Let's make that syrup. So that's 4:8. 1:2. Is it that simple? No, it's not. This is done twice in succession. So, after I do it once, the barrel does not contain pure strawberry syrup. It contains a mixture of syrup and water. And then from that, I remove 4 gallons. So, I'm not going to be removing just 4 gallons of syrup. I'm going to be removing 4 gallons of the mixture. And I need to figure out how much of that mixture is strawberry and how much of that is water. So I need to do this question in 2 steps. The first step is easy. Step 1. Strawberry to water. I start with 12 and 0. I remove 4 gallons of strawberry syrup and I put in 4 gallons of water. So after step 1, I will have 8 of strawberry syrup and 4 of water. 4 has been replaced by water. Now step 2. That's the essential part. What is the total? The total is still 12. And I'm removing how much? I'm removing 4. I'm removing 4 gallons of this total. How much of it is strawberry syrup and how much of it is water. So obviously strawberries to total is 8 is to 12. So 8 over 12 into how much I'm removing, 4, is the amount of strawberry syrup that's being removed. And 4 over 12, which is the ratio of water in the total, times 4 gives me the amount of water that is being removed. I'm more concerned with how much syrup is being removed. So this is the amount of syrup being removed. So what's the syrup left? Syrup left is 8 minus 8 over 12 into 4. Because from the 8, this ratio was removed. And that is 8 minus 8 over 3, which is 16 over 3. So 16 over 3 will be the syrup left over when I remove this amount of syrup the second time round. The rest will be water because this syrup is removed and all water is thrown in. So 16 by 3 will be the final amount of syrup. So what will be the final amount of water? 16 by 3 is the final amount of syrup. Since totally there are going to be 12 gallons, 12 minus 16 by 3 is the final amount of water, which is 20 by 3. So they want the ratio of syrup to water. That's 16 by 3 is to 20 by 3. That's 16 is to 20, which is 4 is to 5. And that's our answer. Syrup to water after 2 iterations of removing 4 gallons and replacing with 4 gallons of water each time gives me a ratio of 4 is to 5. Proportion. What does proportion mean? Proportion means two things are growing or decreasing in the same ratio. So we've seen proportions. Equivalent ratios are actually proportions. The ratios 4 upon 3 equal to 8 upon 6 is a proportion. That actually is a direct proportion. So I say X is directly proportional to Y. X is proportional to Y if X upon Y is a constant ratio. This is the same as saying X is to Y is a fixed ratio. That means if X is multiplied by 3, Y will also be multiplied by 3, and if X is divided by 3, Y will also be divided by 3. The ratio of X's to Y does not change. That is the meaning of directly proportional. Another way to say it is the fraction X by Y will always be constant. If X goes up, Y should also go up in the same proportion. Examples: 4 upon 3 equal to 8 upon 6 equal to 12 over 9, etc. If X is the numerator, then Y will be the denominator value in each of these cases. As X goes up or down, Y also goes up and down in the same proportion. What's an inverse proportion? It says X is inversely proportional to Y. This means if X goes up by a certain multiple, Y should go down by that multiple. That means if X is multiplied by 3, Y should be divided by 3. That's how they behave. So what's the constant here? The constant here is X times Y is a constant. Let's see examples of X and Y. So I'm going to create a column for constant. So suppose X was 3 and Y was 2. Then this constant is X into Y, 6. Now X goes up to 6 and Y should come down to 1. Because X has gone up 2 times, so Y should get divided by 2. And as you can see, the constant stays 6. Suppose X gets divided by 3 and X becomes 1. Then Y should be multiplied by 3. So Y will become 2 times 3, 6. And you see the constant remains 6. Two quantities vary inversely if their product is constant, and two quantities vary directly if their ratio is constant. Let's see an example. Q is directly proportional to P. So directly proportional means Q upon P is a constant. Once I have that constant, I can always figure out Q from P and P from Q. Find the value of q when p is 6. Find q when p is 6. Given that q is 30 when p is 45. So I'm told that qp 30, 45, find it when 6. Well, what do I know? I know that the ratio is constant. So I know that 30 over 45 must equal q over 6, where q is the unknown. Because their ratios must stay constant, equal to a constant. Which is the same as saying, like we learnt in school, q1 over p1 is equal to q2 over p2. Now let's just solve for q2. q2 will be 30 times 6 over 45, 30 and 45. 2 and 3, 3 and 6, 2. q2 equal to 4. Y is inversely proportional to x square. What does inverse proportion mean? It means that product is constant. So that means y times x square is equal to a constant. Or in the language of school, y1 times x1 square will equal y2 times x2 square. The first pair of values of y and x, which I denote by y1 and x1, and the second pair of values of y and x, which I denote by y2 and x2, are related by this equation. y1 times x1 square is equal to y2 times x2 square. Let's plug in values. Find the value of y when x is 10. So let's say y1 times 10 for x1 square. Given that y2 is 20 and x2 is 5, 5 square. Let's solve. y1 will equal 20 times 5 square over 10 square. 20 times 5 over 10 times 10. 2 goes in 5 times. So y1 will equal 5. X varies inversely as y square when z is constant, and x varies directly as square root of z when y is constant. So here there's a combination of several proportions. Let's see how we can keep them all together. So x varies inversely as y square when z is constant. So xy square will be a constant. And x varies directly as a square root of z when y is constant. So x by root z will be a constant when y is a constant. So how do I relate both facts and get one nice expression? Here goes. I write xy square over root z is a constant. Let's try to justify this. First statement, x varies inversely as y square when z is constant. So let's see, if z is constant, this part is also a constant. And I'm saying it's equal to another constant. Let's call it c. So of course xy square becomes c into k, and both are constant, so this stays a constant. This will not vary as x and y will vary. So I have it. X into y square is a constant, so x and y square are inversely related. So it satisfies the first statement. How about the second statement? Second statement says that when y is a constant, x and root z are directly related. Let's see if my expression allows for that. So I'm going to make y a constant. So x into k square upon root z is a constant c. Now since k square is a constant, x over root z becomes c over k square. And obviously a constant divided by constant is a constant. It's not going to vary. It's going to stay some fixed number. So x over root z is now constant, which is another way of saying that x and root z vary directly. So this expression actually does it. It takes care of both conditions in one shot. So now I do my x1 y1 square over root z1 is equal to x2 y2 squared over root z2 to finish off the question. Let's do it in this tiny place. x1 y1 square over root z1 equal to x2 y2 square over root z2. Plug in values and there'll be one value left. First set of values is 16 into 2 squared over 4. Second set of values is x2 4 squared over 25. Root 25, I'm sorry, and root 4. I'll get 16 into 4 over 2. On this side I'll get x2 into 16 over 5. So 4 square and 16 can cancel. Root 4 is 2, it will cancel with one of the 2's. Root 25 is 5. So I'll end up with x2 is 2 into 5, 10. Please check that x2 equal to 10 will satisfy this equation. Of course, using the equation was easy. Setting it up was the complicated part. P varies directly as the product of Q and R, which is saying P over Q times R is constant. If P is trebled and Q is halved, what is the change in R? So let's start with P1 over Q1 times R1 is equal to P2 over Q2 times R2. Let's keep P1, Q1, R1 the same and let's see what P2, Q2, R2 become. Well, P is trebled, so that means P2 is 3P1. So I'm going to write 3P1 for P2. Q is halved. That means Q2 is half of Q1. Q2 becomes Q1 by 2. What is the change in R? And I need to find out R2. Let's solve. So P1s cancel, Q1s cancel, and I get 1 over R1 is 3 over R2 by 2. Solving for R2, I get R2 over 2 is equal to 3 R1 by cross multiplying. And so R2 is equal to 6 R1. So what is the change in R? R1 has become R2, which is 6 R1. So the change in R is that R has been multiplied by 6. It has increased 6-fold.